Today we're joined by Dr. Peter Clarke. Peter is the manager of our colour laboratory. He has over 30 years experience in colour measurement sciences. He's written as well as co-authored a number of good practice guides to making reflectance and transmitted colour measurement. He's a member of the Society of Dyers and Colourists, a member of the BSI Standards Committee for the Measurement of Textiles, where he oversees all aspects of colour measurement, and also the UK representative for Division 1 of CIE, which is the International Lighting Committee. We are very proud to have him as a member of our team and excited to hear him speak today. So with that, I'm going to hand you over to Peter.
Hello. So today, I'm going to talk about why we would measure colour, go through some of the basic principles of the measurement instrumentation, look at some of the colour scales and colour species, and then concentrate on sort of contrasting between visual and automatic measuring instrumentation, some of the advantages, some of the disadvantages, and then looking at some of the compliance and calibration of the equipment, and then finishing with a short bit about the edible oil methods handbook that we have. So why? When you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is of a meagre and unsatisfactory kind. These are not my words, but these are the words of Lord Kelvin from Victorian times. Basically, if we can put numbers to it, then we can put numbers to our colour and we can communicate that colour to someone else. So, if we consider our vegetable oil, what do I know about it? Is it changing? Is this batch darker than the previous batch? Is it getting more red? What do I know? I'm not really certain what's going on. So if we have our measurement instrumentation, we can make fully quantified colour values. We can put some tolerances to it. We can measure it. I can get some numbers out. And then I can look and check those numbers and say, these numbers are within the tolerance or my specification or my customer's expectation of the product. So this is a current visual instrument, Lovibonde Model F. Has a number of glass racks. We can put our sample in a number of cells of different path lengths. So let's look at some of the principles behind how this measures our colour. So this instrument has a light source, and we're shining that light source down two optical paths. So one, we're going through our edible oil in our glass cell, and the other, we're shining it through a path where we can put different coloured glasses in so that visually you can look down the eyepiece and see what's happening. So here's our light coming into the eye. At the moment the colour isn't matched. We're looking at a circular field. So one semicircle is actually our sample. The other semicircle is the colour that we're creating to try and match to our sample. So what we will do is we will slide different coloured glasses in, being edible oil, reds and yellows mainly. So we'll put biggest colour in first, maybe, add a little bit more, am I guessing there? Till finally I've got enough pieces of glass in of different colours and the combination adding up together gives us the same color as we have with our sample. Then I can look at the top of the instrument and I can read off from the glass racks what colors I actually put in, and I can add them up and I can get a result. I've quantified what I'm looking at. So here, 1.1 red, 10 yellow. If I'm looking at my sample, and this is quite important if you're looking with an electronic or automatic instrument, I need to make sure that my sample is nice and clear. Quick way to do that would be to look at something like some text behind it. If I can read it clearly through my cell, I know that I've got a good sample. There's no sort of cloudiness. It doesn't need heating up or filtering to make it nice and clear. When I've got a nice clear sample, I stand a good chance of getting a good measurement. So if I look at the Model FX, the edible oil instrument, again, we can put a number of different cells in, different liquids. The optical principle behind this, very similar to the visual, except we just have one measurement path. So we have our light source, we have a collimated beam of light shining onto our sample in our glass cell, and then we go to a detector. So a little bit more simple, no color matching involved by an external observer. We just press the measurement button. We've got our nice clear sample there, and we get a measurement. So what kind of scales can we make a measurement on? Well, electronic instruments from Lovibonde can do a variety of different color scales. We can do all the edible oil, AICS, Tintometer, Lovibonde, beta carotene, chlorophyll. But some of our other instruments can actually do some other colors as well. FAC, Gardner, platinum cobalt. So a good variety of colors. So let's have a look at some of these other color scales. We might be looking at beer, and typically if we're looking at natural products, a lot of natural products are amber in color. So these tend to be sort of what we would call a single color scale. So you go from a light color to a dark color. So it's like you've got your 3D color space and you've drawn one single line in the color space, and then you're trying to match your product to somewhere on that line. And you could apply arbitrary units. You might call the first color 1 and the last color 20 or whatever, however many you have in the color scale. Looking further here, this is a very, very early, more than 100 years old comparator that someone has built using Lovibonde colored glass. And this is for a single color scale. This is actually for beer. You put your color of beer, you stand that on that little shelf in the middle, and then you look to the left of that and you match the color of the piece of glass that is closest to the color of your beer. So a typical color scale, as I've said, you've got a series of colors and this sort of one-dimensional scale goes from light to dark. This is a representation of the Gardner Colour scale. So a lot of these color scales are defined in specific standards, from ASTM, AOCS, Indian standards. And this scale has a range of 1 to 18, path length of 10 millimeters. And this scale is used for grading color of liquids, resins, varnishes. And also things like lecithins in sunflower oil and linseed oil. So it has a sort of edible oil connection. When you look at it with glass standards, obviously you've got your 18 standards. When we can look at it with an electronic instrument, we can actually interpolate between those colors, so we can actually get a much smaller resolution in our color matching. We can go down to 0.1 of a step. But when we do go down to that sort of level, we have to be a bit aware of the kind of tolerance range we might get on our measurements. So although we can measure to 0.1 of a unit, our actual tolerance on the actual product, when we're actually doing the measurement, maybe something like 0.2, 0.3. So you have to be a little bit careful with balancing your tolerance against the resolution that the instrument can measure. So here, just for comparison, some people have had some colors that they've put together on the Gardner Colour scale, and you can light that up, and then you can see physically that these physical samples following that sort of light to dark trend in the single color scale. If we're looking at our model F, where we've got red, yellow, blue colors, where we're combining together to give a multi-dimensional color, so we can match, you know, a lot of different colors here rather than just a single color. So this is the beauty of a visual instrument. We also need to remember, if we're looking at the Lovibonde scale or the ASCS Tintometer scale, that they're not linear scales, they are logarithmic scales. So as you get darker, the colors get closer and closer together. So if you have a color around about the sort of 5, 10 level, you can see you can have, you know, quite a little range, but a small number range. If I'm higher up on the scale, it may be 40 or 50, everything's very close together. So is my number 40, 50, 60? Not much difference in the color. So we can see this if we look at our colored rack. So you have the 0.1s, the units, and the 10s. If you're looking at the last sort of 5 steps in the yellow here, you can probably see that they're actually quite close together. There isn't much color difference going on there. So if we're using this for measurement, we're really wanting to get into the units range where we can have quite a big color difference between steps, so we can get a better resolution on our measurement, a better idea of what our color actually is. You can see here a similar thing with the reds, and typically on the last 4 steps there, 40, 50, 60, 70. Is there much? Visually doesn't look much different. If I'm looking lower down the scale, I can see a nice progression of color. So this sort of feeds in to the path length. So we're recommending Lovibonde units. If you were in some of the earlier webinars talking about total of our red, yellow, blue or neutral values, if they're greater than 20, we should really be looking to reduce the path length. So we have our logarithmic scale. I have my color, maybe in a 5 1/4 inch cell. I've got a value, what, 45, 50? Not really that certain. There could be quite a little bit of variation there, plus or minus 5 value, plus or minus 6, who knows? But that's quite a big number. So if I reduce the path length, reduce it down, put it in a 1 inch cell maybe, and I've brought the color down here to maybe about 12. So if I've got a variation here, move a little bit either side, well, you know, I'm going to have a tolerance then maybe on my color of 0.5, 0.2, 1 unit, much, much smaller variation than if I'm much, much higher up the scale. And now visually here, You can see that we're shining light through the length of the cell, so a 5¼ inch cell on the right and a 1 inch cell on the left. And you can see that difference in color as we're now operating the instrument in its most sensitive range. So why would we use a visual instrument, or any instrument, come to that? Because without an instrument, it's impossible to communicate color. We've only got to look around us, look at many of the sort of international companies and their brands. A lot of brands use red as a color, but their reds are different. How would you describe their red? Is that Jinx manufacturer using a particular shade? Is it an orangey red? Is it a blue red? How do I describe that? And how would I actually replicate that if I was someone else? How would I describe that color? You know, how do you describe the color of your edible oil? Well, it's amber. Yeah, okay, light amber, dark amber. You know, so I need some sort of instrument to be able to communicate what sort of color I'm measuring, and someone else to be able to replicate what I'm doing. So visual instruments, they're simple, but also because we have a controlled light source, we're always measuring in the same way, so we have a consistent background, and we can remove interference from other colors. If you change your light source, you're going to get a different look to the color. You might notice at night time, if you have your car parked under one of those sort of yellow type street lamps, your color of your car looks very, very different to what it looks like in the daylight. So we control our lighting conditions, and we know that we're going to get a consistent measurement with someone else who's using the same lights. And we're using an instrument so that we can actually record what that color is. Our memory of color is not that good. When you take your holiday photos and you say, oh yes, the sky was blue, you know, the sea was a nice greeny blue color. Actually, when we get back home and try and remember that, we actually overemphasize the color. We like our colors to be much more saturated than they actually were in real life. So our memory on color is not good. So if we want to, if we're in our refinery, say, we need some sort of accurate information on our color. We've got a process running. I want to know if it's going too dark or too light. I might need to bleach the color some more. I might need to do less bleaching, but I'm going to need some sort of accurate information as to how I control my process. What do I do next? And if we've got numbers to it, as we said very much at the beginning, we've got some numbers, I can then put a tolerance range on those numbers, and then very easy to make a pass-fail decision on my product or something that I'm buying in from a supplier. So I can make a decision on it because I put numbers to it. Okay, there are some things to think about as well when we're using a visual instrument. Sometimes the operator, their personal perspective, their feelings, their desires, is their mind on the job? Are they, you know, how am I feeling today? Am I thinking about the weekend, what I'm doing at the weekend? Big thing with visual observers is my observer colorblind? I really need people with normal color vision. 1 in 12 males will be colorblind. Only about 1% of females. We need to look at, are we doing tests to make sure that someone's got normal color vision? Because I might not get the result I'm expecting if I'm using the wrong person. Also, if I spend all day looking down an eyepiece trying to match colours, I could get eye fatigue. The eye gets tired. If I stare at the colour for too long, I'm really not going to be in a position to make a good colour match. I should be looking at the colour for a shorter period of time, 5–10 seconds, enough time to make a good judgment, but not too long. But the colour is just overwhelmed, and I then make a poor judgment. It might be that the person is physically tired. Anything we do, we're just not as good at it if we're tired. And also, you need to consider that because everybody's eye is different, everybody sees colour in a slightly different way. So we're going to have variation between our visual observers. So let's have a look at some colour matching with our visual instrument. So if we look at a lot of the standards, we need to test people's colour vision, but it shouldn't be a one-time thing. People's eyesight changes. You go to the optician because you're focusing, you get new glasses. So you should treat colour vision testing in the same way, regularly retest, make sure that people can see colour properly. Also need to mention, you shouldn't be doing it wearing tinted or light sensitive spectacles, because this will give a different colour. So you'll give a colour overlay over what you're trying to look at, and that will make you less sensitive to certain colours in certain parts of the spectrum, depending on what colour the tinting is. So you should have no tinting, nice clear glasses, so you can get a good look at the colour. So these are some colour tests from the Ishihara colour series. So there are a number of different things here going on. The one on the top left, anybody can see that, so you should see a number in there. It's number 12. Some of the others, depending on what your colour vision is, you might see one number, you might see a different number, you might see a 2, you might see a 5, depending on what your colour vision is. So you can test someone's eyesight with these. Some of these tests also are available with a line that you can get someone to trace from one side to the other. So they don't need to be able to tell you what a number is if they're not very literate. You can still get them to trace a line, and you can work out from the answers they give as to whether they're colourblind or not. So a good way of testing someone's colour vision. So if we're looking at ASCS standard for visual matching, so CC13E92 will state you need to use at least 2 observers for your measurement. So let's look at some colour matching scenarios. So here we might have one person say it's not a match, one person say it's a match. So if you have an odd number of people, you're going to get a consensus opinion. So if I have a third person says it's not a match, then the consensus opinion is it's not a match. And look at again, we might have a match, not a match, and then when the third person says yes, it's a match. So we have a consensus that that is a colour match. If we look again, if the first 2 people give me not a colour match, and the consensus is that's definitely not a match. And again, looking at this, you can say yes, that's a match, that's a match. So depending on how good or how often people agree with each other, you're going to need a number of visual observers to make a reliable colour measurement. Be certain that you have some sort of consensus that it's a match or not a match. But then we need to sort of look at that in the context of, I need to comply with a specification or a standard. These things take time, my measurement time and my compliance time. Now I want these both to be fast. But what is reality? Probably, if I'm looking here, I'm probably getting a slow sort of time on my measurement, but I'm getting a high compliance with that. So I'm very, very certain that I've got a good specification, I've got a good measurement. If I try and speed things up, I might do a very quick measurement, but I'm adding uncertainty here. I can be quite variable on my measurement if I haven't spent enough time making my measurement. So my compliance then becomes low. So I need to kind of balance this. So let's look at how this compares to what an automatic or an electronic instrument can do. So some of the things that we considered for the visual instrument. So we need some sort of instrumentation to communicate the color. Again, we have a light source, controlled lighting conditions, to remove the background effect to our color measurement. We can record some sort of results. We can get some sort of accurate measurement out. So we can correct our refinery process, and we can have some sort of tolerance on our pass-fail, so my customer is happy, or if I'm buying something from my supplier and I've checked what they've given me, I've got a tolerance on what they've sent me. So all those sort of things. But some of the advantages of an automatic instrument, I take out the observer thing, so I take out personal perspective, I take out looking at color blindness, I take out eye fatigue, I take out physical tiredness. The machine never gets tired as long as I keep the machine clean and operating within the instructions. So I might need to regularly do a baseline to the machine. Then I'm going to take out a lot of these observer effects. I'm also hopefully going to reduce variation in my measurement, because generally visual observers can be more variable in their color matching than I will get from an instrument. An instrument can be very repeatable day in, day out. So Lovibonde range, we have several instruments that are available in the PFXI series, which has the most range of color scales, of 50 plus scales that you can choose from on this instrument. Edible oil scales, the Gardners, the petroleum stuff if you're interested, pharmacopoeia stuff, beer scales, lots and lots of choice of scales on this particular instrument. If I move to the Lovibonde FX, this is a more accurate instrument than the PFXI range, but this is aimed purely at the edible oil measurement. And you can see here, got some results from using a glass filter in the instrument. This filter has been calibrated at the MPL in the UK, and the data has been compared with that, but I'm getting a very, very repeatable result. That's 30 measurements plotted on that graph. You can see they're virtually all on top of each other. So there's no significant difference in that measurement data. And it actually matches quite well what we're getting from the MPL. But you're going to say to me, that's a filter, but I'm measuring a liquid in a glass cell. So we also looked here at using a Lovibonde reference liquid in a 5¼ inch cell, get a slightly bigger spread in the values because we're using glass cell, but you can see again, everything's pretty well repeatable and on top of each other. And when I actually do the measurement and read the numbers off, I'm pretty well getting 3.3 red and 22 yellow on this sample for all 30 of those measurements. A little video here which shows the use of the model FX. So very simple, got a screen button bottom left turns the instrument on. You get the splash screen and tell you what the serial number is, tell you what firmware you're running, and you get this bar as it boots up. And now here it's ready to carry out a measurement. You're going to need to do a 0 or a baseline measurement. That's the first thing you do. Make sure the instrument is empty. Do the 0 measurement. May take a little bit of time. Does a measurement with the light on, a measurement with the light off. And now the instrument is ready to go. You may be needing to heat your sample up. Maybe you're measuring something like palm oil, which is solid at room temperature. So you're going to need to get the temperature up, set the target temperature. And the instrument will then show you what the heater block temperature is. And you'll get an icon that's showing your heaters on. And I'll also show you what the actual temperature of your sample is. So you can see whether your sample is actually at the same temperature as your heater. You can select your color scale from the menu icon. Everything's driven by these 5 buttons underneath the screen that change depending on where you are in what particular menu. So you can choose your scale. And also very similar with the menu. You can choose your path length. Very standard path length, but you also have a user path length if you want to actually put in your own path length. So now, instrument's all set up, right path length, got a heater on if we need it. So we need to take our measurement. So with the FX, samples go in towards the back. So you put the cell in, make sure it's pushed towards the back. The measurements on the sample chamber there tell you where the front of the cell should be. And then we press the measure button. Measure button only appears after you have done a baseline. So you can see here the sample temperature and the temperature of our heater block, pretty similar. So we know we're measuring it as the temperature that we said we were wanting to measure at. So let's look at some of the things that we may be complying with. So we're working to a particular standard, possibly. We're using our Lovibonde RYBN. So we may be working to the AOCS CC13E for our visual, or CC13J, or the ISO standard 15305, or MS252 part 16. We might be looking with Lovibond Yellow. We may be using AOCS Tintometer. Again, AOCS standards describe that. Or we might be using 10:1. Also on the instrument, we have chlorophyll, so AOCS CC13D55. And we also have beta carotene, BS684 section 2.2. So we can display one of the sort of top 4 scales with the chlorophyll and the beta carotene if we also want those measurements as well. So if we look at our automatic instrument, we can probably find that our measurement time is pretty fast. And also, because of the repeatability and the accuracy of the instrument, our compliance can be high as well. So it's a sort of win-win situation. So to have a little bit of a checklist here to make sure that we have confidence in our measurement. So if we're using our visual instrument, our Model E, our Model F, is it unmodified? Are we using the recommended bulbs? Is the internal okay? Is the sample chamber in our visual instrument, is it nice and white? Maybe it needs repainting if it's turned sort of yellowy. So is our instrument in the best condition it can be? Is it clean, undamaged? Because if we keep our instrument clean, we haven't damaged it, it's going to work much, much better. Are we using a clean cell in the instrument? Have we made sure that the end windows on the outside are nice and clean? We haven't got oil dripping down them. That's the sort of thing that in a automatic instrument is going to scatter light, give us a darker reading than we might expect. Do we have our instrument regularly serviced? Is it looked after? Do we do regular checks on it? If we've got an automatic instrument, does it have the latest firmware? Have we been to the Lovibonde website or contacted support? Have we downloaded that, installed it on the instrument? Very simple process. If we're using a visual instrument, all the standards recommend you use 2 or more observers. Are we using 2 or more observers for our measurement? Have we tested their eyesight, their colour blindness? Are we, in our results, looking at the variation between observers? Have we looked at our tolerance? Are we using the right scale for what our customer or our system is using? Have we looked at our sample? Was it nice and transparent and clear? Did we heat it up if we needed to? What temperature? Did we stir our sample? Quite often, if we've heated the sample up, you can get structure from the heating. So a good idea to, just before you measure it, give it a quick stir, shut the lid of the instrument, wait 3 or 4 seconds, everything to settle down, do our measurement. And if you've heated it up, that's probably the best time that you're going to get the best measurement for the colour. Are we using the appropriate cell path length? Are we complying with our standard? Have we moved to a shorter path length if we've got Lovibonde values adding up to more than 20, so that we're operating at that part of the colour scale where we get maximum resolution in our colour? And then lastly, have we validated that our instrument is working properly? Because everything we do here is predicated on our measurement instrument operating correctly, whether that's a visual or an electronic instrument. So for our instrument validation, we can use some sort of reference filter or a reference liquid. And if ideally should be using something similar to the values that we're typically measuring on our sample, because if we know that we're looking at a filter that's been certified, we've measured it, we've compared the value to the certificate, we've got similar answer, we know that our instrument is working well. We're certain that the instrument is not the problem then if there are other issues in our measurement. If we get a result that we're not expecting, we need to go back then and look at, is the sample hot enough? Did we heat it up when it needed heating up? Did we filter it? Was our cell clean? Did we check that there wasn't any oil spilt on the outside of the end windows? Are we using the right path length cell? Quite often when we get the wrong result, we put it in the wrong path length. So if we're looking at comparing different types of instruments, we have the Lovibonde Universal Verification Standards. It's a set of 3 amber standards. So they have one set of Lovibonde values, but it has 3 tolerance ranges. So it has tolerance ranges for use in a Model FX, for use in a PFXI, and also in the Model F visual instruments. The tolerance ranges are different as you move from the automatic down to the visual. The tolerance range gets wider to take account of things like observers, the accuracy of the instrument itself. But you can put that filter in your instrument, take a measurement, and look to see if your measurement on that particular type of instrument is within the tolerance range quoted on the certificate. If it is, we can be pretty confident then that our instrument is functioning correctly. So If it's out of range, might need to go back, check the instrument setup and retry. Did we do the baseline properly on our electronic instrument? Did we make sure that there wasn't anything in the sample chamber? If we continue to have problems, get the conformance filter that was supplied with the instrument out, measure that. Does that give a problem? If it doesn't, maybe look at where we're going, contact support here at Lovibonde for some advice. So I've done my measurement, I've checked that I've done everything on the checklist, I've checked my instrument compliance, I know that my instrument's working well. I need to communicate my result then to someone else so that they can replicate that measurement if they need to. So what should I be giving them in that? So I should be giving them the color scale that I use, whether I was working to a particular standard. I should give them a date of when I measured that. If I've got a product that might change over time, like my edible oil, I need to know, if I'm measuring it the next day, I would expect a similar answer. If I'm measuring it maybe a year down the line, there might be some physical change to the sample. So I can judge what my measurement on that particular sample is if I've got the date information. Also, if I'm in a refinery type environment, where the process is changing hour on hour, then time might be relevant. So the sample I took at 3 o'clock, we'll see what the process was doing there, but the process might be completely different at 5 o'clock because the filters need changing or the amount of bleaching's changed. Might be relevant if I'm feeding that back into the process. So useful to know who made the measurement. I can look back at the data then, I can see if there are trends, I can see if someone's struggling with a particular type of measurement, and maybe then there's some more training needed. I also need some sort of description of the sample so I know what I was measuring. I might have some sort of reference number, a batch number, so I can identify, yes, it was sunflower oil, but it was from a particular batch. And if I heated it up, so my palm oil or whatever, I heated it up, what temperature did I heat it? Did I heat it to 40, 50, 60, 70? So also some comments on the sample. If you need it, was the sample turbid? Was it dirty? Did you need to filter it before you measured it? What path length I use, most important, because you're going to get a different color if you change the path length. What were my actual values? So I put my color values in if I'm using Lovibonde, my red, yellow and blue, but also I need to put in the neutral value because the neutral value is part of the measurement. It also makes it easier if someone's trying to replicate the measurement that they know that you use some neutral in your color match. And then maybe any other information that my organization or my customer may be interested in. And then maybe some comments relative to the color match. If you had some sort of difficulty in matching it, you might want to know closest match I get. And then we have the Lovibonde Edible Oils method book. This kind of summarizes a lot of the methods and the things that I've been talking about here. So you've got step-by-step instructions, it's got the stuff about how we prepare our sample, a recommended measurement condition, how we report our results, and it's a very good guide. If you want to refer back to things, how do I do this? What do I need to do? And that's available, I believe, on our website. Okay, well, that's the end of my talk. So now open for questions or comments or whatever. Thank you.
Okay, thank you, Peter. So we are now at the question and answer section of the webinar. So if anyone does have any questions, please place them within the Q&A box. And we'll try and answer some for you now. And if we don't get to answer them, we will respond to you via email with an answer. So I have a couple of questions, Peter. If we already have one set of conformance filters, can we recalibrate as Love's standard?
No, the Love standards are a special set of standards that has been specifically chosen and looked at to make sure that it gives consistent results across all the instrument types. Depending on what is used to make up a filter, you can get issues if you're using multiple colored glass. So they need to be chosen very carefully to make sure that they work with the geometries of all the instruments.
Okay, thank you. Someone has asked when a neutral color should be used.
So in your visual instrument, when you're making the color match, you're going to use the or for your edible oil, probably your red and your yellow to get the color right. And then we use the neutral if our sample looks too bright compared to the color match. Because we put several pieces of glass in to make a color match, we need to dull down sometimes the sample color. So we put a neutral glass in just to bring the brightness down, because it's much easier to match our color if the brightnesses are the same. And if we're looking at our automatic instrument, the automatic instrument within its database will look at what the color is, the measurement, and it will also apply the neutral value in a similar way to what you would do in a visual instrument. So it's quite important that you actually use the neutral, especially if you want to use something like the Love's filters.
Okay, can I just ask for everyone to put their questions in the Q&A box, not the chat box, please? That would be great. So someone's asked, where can they get a Lovibonde Model E from, Peter?
Well, the Lovibonde Model E is a very, very old instrument. So it was the predecessor to the Model F. It's actually an obsolete instrument now. So if you were wanting a visual instrument, you would be buying a Model F.
Great, thank you. And also someone has said, if they detect a blue color in crude palm oil samples, what does it indicate?
Okay, generally, if we're looking at an edible oil, unless we're looking at olive oil, if we're getting a blue color coming up on our instrument, usually means that our sample is cloudy, it's turbid, it's dark. So the instrument or your visual observer will need to add blue to bring the brightness down. So blue is usually an indication that your sample probably needs heating up. Exception to that is olive oil, because olive oil has that sort of greenish color, so you will have some blue in. But generally, things like palm oil, if you get a blue color, you need to warm up your sample. So typically on a palm oil, I would be recommending heating it up to about 80 degrees. It might look liquid at 40 degrees, but it won't necessarily be fully melted, because it's a multi-fraction oil. So the oil is made up of different chain length molecules. The shorter ones will melt at lower temperature, but the longer ones will still not be melted, so they will act as scattering centers. They will scatter the light sideways, so you'll get a darker reading than you should. So you need to then heat the sample up a little bit more, and then eventually they will dissolve. So I guarantee that by 80 degrees they will dissolve. So if you've heated your sample to 40, heat it to 50, take another measurement. Is the blue still there? Has my other colors gone down? Probably, because the chains are melting and I'm not scattering the light and losing it. So if you keep increasing it by 10 degrees, you can also then note the point at which the blue goes away, or my color values, if I'm looking at red and yellow, stabilize, they stay the same, I change the temperature, but nothing happens. So I then know that my sample is fully melted. So blue is really an indication that there's some sort of either turbidity or my sample needs heating up.
Okay, thank you. So how can I determine the limit of detection of the Lovibonde PFXI 950? The normal method is by using a blank sample. However, the reading will just be 0.
Okay. Really going to depend on what sort of resolution or what type of sample you're measuring. Obviously, if you're looking at the limit, you're going to need to have some sample that has a little bit of color in it. You can do this with a visual instrument as well. So you have something that's very light with a little bit of color in it. Put it in the instrument, do a measurement, or get someone to color match it. And then you can see if someone can detect 0.1 in any of the Lovibonde units. But yeah, you need to put something in it. And you also need to do repeat measurements just to be sure of the type of range that you're going to measure over. So I might be getting something that's giving me 0 red and 0.5 on the yellow, but if I do multiple measurements, I might get 0.4, 0.6 for someone. So I just need to do multiple measurements really to get an idea of what sort of range I'm going to get out of the color. If I've got something that's with no color, I mean, I would recommend if you're looking at very, very light samples, trying to use the longest path length cell that you can, because that will create more color so that you can actually measure it. Yeah, shorter the path length, obviously you're going to get a very light color, which might mean that you're going to keep reading 0 for your measurements. So you then, in that case, would want to get it in a 5 1/4 inch cell, so that you can actually see some color. But yeah, you really just need to do some measurements with some samples just to work out what your tolerances are.
Okay, so may I know the value of ASTM 1500 in your instrument display in 0.5 intervals or with 2 decimal points?
In PFXI range, you will get the ASTM color scale, I think, to 1 decimal point. Sometimes instruments will display 2 decimal points, but you have to be a bit careful with the instrument display against reality, really. It might give a measurement to that, but how accurate is that? What's the tolerance on that? So really on something like the ASTM scale, you can really only rely on an instrument to 0.1 of a unit. So it gives you just that little bit of an extra edge over, say, a visual instrument. But you've still got to think about what your tolerance is. It just might mean that instead of saying, I'm matching to, say, 2.5 on the scale, the electronic instrument has actually given you a match to 2.2, so somewhere between points that you might have got on a visual instrument. But you also then need to look at what your tolerance is on top. It just then means that your tolerance range is probably a bit more representative of where your actual sample is. So I might have a tolerance range of 0.3, 0.4, but I then know the center point of my tolerance range a little bit more accurately because the automatic instrument has given me that rather than the fixed points that I can only match to in a visual scale.
Great, thank you, Peter. So I think we're at the end of our webinar now.